In modern airports, many passengers who arrive early or have a long transit time really hope to visit, shop, or eat in the airport, or even in the surrounding areas while waiting for their flight. But heavy luggage just becomes a burden on their actions. Taking Beijing Capital International Airport as an example, its luggage storage counters are located in pretty remote areas. And honestly, the paths are quite complicated. Passengers often need to spend a lot of time just looking for storage points, which results in inefficient service and yet a poor experience overall. The existing measure is to provide passengers with luggage cranes. This is just not convenient. This inconvenience not only affects the user experience, but also it kind of contradicts the building inclusive, safe, and sustainable urban infrastructure proposed in the United Nations Sustainable Development Goal 11. Therefore, this design project is people-centered, really focusing on the real needs of passengers, and proposes a new concept of luggage storage system aiming to promote the convenience and sustainability of airport services. Here are some predecessors. The first is Starship Robot Delivery, which can deliver takeout to users. This service model can be combined with airport luggage storage. Replacing manual service with delivery vehicles can greatly improve the current storage problem. The second predecessor is Manual Luggage Delivery Service. Staff can deliver their luggage to the airport according to user needs. The luggage collection service model can also expand the service model of airport luggage storage. The third predecessor is the Australian Post Express Locker. This self-service package collection form can be used in the airport. Users can handle the storage service by themselves as needed. I created a conceptual framework based on the problem space. This framework will help me come up with design concepts that solve the problem more accurately. Considering the remote location of the storage counter, I hope to replace the fixed storage counter with a mobile platform. I used the shopping cart as my conceptual model to experiment and design the unmanned luggage storage car solution. The experimental process shows the process from the user's mobile phone reservation to the arrival of the smart luggage storage car, and the process of the user returning to the airport and picking up the luggage. The experiment found that this form cannot protect the safety of the luggage, so I made an iterative design. I redesigned the shape of the smart unmanned luggage storage car and changed the storage method. I also increased the storage space for luggage, which made the concept more reasonable and perfect. My second concept is the luggage delivery car. The luggage delivery car is driven by staff and goes to the location of the passengers. This solution can also help passengers solve the storage problem, but manual participation can be replaced by intelligence. I made an iterative design. I made a scale model and conducted experiments at the airport. The experimental process simulates the actual needs and behaviors of passengers at the airport. The test results show that this design concept can meet the needs of passengers. My third design concept is to place self-service luggage lockers at multiple locations throughout the airport. This may also solve the problem of remote luggage lockers. In the future, I will continue to conduct in-depth research on the demand and services for airport luggage storage. I decided to use smart luggage storage vehicles as the starting point for my solution and consider more optimized solutions for deeper problem spaces. In the final design project, I will present a systematic design concept plan. I'll show the integrity of the design in detail through interactive models and service processes, while fully considering sustainable development goals.